naman tayong bagong gagawing project. So, ano na naman yan? Oh, ito ay Adafruit HUZZAH. Ang kanyang chip ay yari sa ESP12S. Oh. Diba? Kinabitan na natin ng pin header. Oh, yan, may pin header na. Oh, ayan na naman ang gagawin mo dyan. Ha? Ang gagawin natin yung onboard LED niya, yun, i-blink natin. Ano ba yung anong yan? Ito nga pala ito ay Wi-Fi at microcontroller na module. Oh, yun yung kanyang antena. Wi-Fi. Pero gagamitin natin siya ngayon as microcontroller dahil i-blink natin yung LED. Paano yan? Ha? Meron tayong kailangan isa pang device na gagamitin. Ito. Ano na naman yan? Ha? Ito yung tinatawag na USB serial. Oh. Para mag-connect itong ating microcontroller sa computer, kailangan ito. Ito UART, Universal Asynchronous Receiver Transmitter. Para makapag-communicate yung computer, dito yung computer at saka microcontroller, kailangan pa ng isang device. UART to USB serial para may connect sa computer. Oh. Computer, UART to USB serial, and then microcontroller. Okay? Pero kailangan nito ng driver. Kasi itong ating UART o USB serial, ayun meron siyang 6 na pin. DTR, RXD, TXD, 5 volts, ground 3.3 volts, 3B3. Okay? At yung chip niya, ang gamit dito ay yung tinatawag na CP2102 chip. Oh. Yung pinaka USB serial niya. UART. Kakabit natin ito sa computer. At kailangan ng driver ng chip. Ito muna gagawin natin. Kabit natin at installan natin ng driver. Ayun. May power na siya. already uploaded the driver, and then let us now check if the driver is already installed. Good day to everyone. Here is now the schematic diagram of HUZZAH CP2102 blink LED. So we are using computer and then the CP2102 UART bridge USB serial, which is also connected to Adafruit HUZZAH. For our circuit to function, we are connecting this CP2102 to the desktop. Okay? So that there is a communication protocol used for this circuit. That is a serial communication, transferring of binary digits 1 by 1, 0101 to the UART. Why did we use CP2102? Why not connect the PC directly to the Adafruit HUZZAH microcontroller? Because in this module, we have no onboard UART, which is responsible for serial communication, okay, to extract the bits, raw data from the code. So we're using this desktop PC, personal computer, for coding and also for serial communication. Inside the CP2102, it has 6-pin DTR, 5 volts, ground, transmit, receive, and then 3B3, 3.3 volts. If this is USB cable, we are supplying 5 volts from PC to the CP2102. And this CP2102 has a converter that converts the 5 volts into 3.3 volts. So this CP2102 has 5 volts and 3.3 volts. Aside from that, we have the DTR, ground, TX, RX. We only use 5 volts, ground, TX, and RX. And also, when we connect the USB cable to the CP2102, LED, power LED off, this module turns on. So we're using 4 pins. 5 volts connected to the B+ of HUZZAH microcontroller. Ground to ground, 5 volts to be connected to B+, then ground, back to ground. This is the flow of current. And then TXD to RX of Adafruit HUZZAH. And then TX of the HUZZAH Adafruit TX to RXD. These two lines are what we call power logic, or the supply. HUZZAH, it is capable of receiving power, or we need to use supply from 3.3 volts to 3.3 volts for the power of this HUZZAH to 6 volts. But in our case, we are using 5 volts to power this Adafruit HUZZAH. Why is it that there is no logic level shifter between TX and RX and TX to RX of this Adafruit N2102? Because these two lines are communication lines. Once it's transmit, it is being able, it will be received by the Adafruit. And once the Adafruit transmit, it will receive by the CP2102. The logic level Okay? O signal voltage. TX to RX should be 3.3 volts. So the logic level of this TX to RX, because we're using 5 volts here, and then goes to the RX of the Adafruit, which is capable of receiving 5 volts. 5 volts of signal output level, or the logic level, 5 volts. Why is it that it is capable of receiving these 5 volts? Because there is a logic level shifter inside the board of HUZZAH. That is the feature of this. There is logic level shifter. Logic level shifter. There is a shifter inside the board of the Adafruit HUZZAH. So we don't need any extra components to be connected between the two in order to produce a 3.3 volts between TX to RX. Once the CP2102 transmit the data and it is being received by the Adafruit HUZZAH convert it into 3.3 volts. So this one is 5 volts for the TX of the UART. Converted it to 3.3 volts. So it has a logic level shifter inside this onboard. Logic level shifter onboard. Then TX, it is 3.3 volts. Back to the RX. Okay? Since this is capable of receiving data transmission of 5 volts. So it's okay to receive 3.3 volts from TX of this HUZZAH. Okay? So this HUZZAH has a built-in or onboard logic level shifter that shifting the voltage from TX 5 volts, it will become 3.3 volts because of this module has a logic level shifter on board, or it was designed with the logic level shifter. So this GPIO 0 is used. Okay, this GPIO is used when we are going to upload the code. They are at the same time. When you're going to insert the USB, it must be together. It must be at the same time. You must press the button while inserting the USB when encoding or for coding or encoding. And this reset pin is used for checking for the uploaded code, checking if it works, or for running the uploaded code. This is now the onboard LED. So this one is the one we're going to blink, the onboard LED. Okay? PC, CP2102, and then HUZZAH. We need this UART, USB serial, to communicate PC or to connect PC to the microcontroller, because this microcontroller has no onboard UART. Unlike other microcontroller, it has no onboard UART, and this one needs driver. We need to install the driver for this CP2102, and also we also have a board driver for this Adafruit HUZZAH. It is under ESP8266, and the JSON file for the Arduino IDE. So that is the operation. We are not using any logic level shifter because it has a logic level shifter inside the Adafruit HUZZAH. So once we uploaded the code and then reset the button when we are uploading, GPIO 0 and USB must be at the same time. When we are, must be at the same time, we press the button and inserting the USB to the PC. And then resetting it. Now the LED will blink. Okay, this is the Wi-Fi antenna. Okay. That is the Wi-Fi antenna. The default pin is connected to the GPIO 0, hashtag 0. As you can see here, the output is inverted. When the onboard LED turns on, the external LED turns off. We need this current limiting resistor 330 ohms to limit the current. So it has an inverter gate for the output of the onboard LED located at 0, hashtag 0. We only use the power lines from our CP2102. Only the 5 volt supply and the ground.